All right, we're going to be graphing absolute value today. Just a quick review. When we went to solve for absolute value a few sections ago, we had to solve 2 times. So if I were to solve for the absolute value of x minus 3 is equal to 7, I had to set x minus 3 equal to positive 7, and then a second time where x minus 3 is equal to negative 7. So when I went to solve, I always ended up with 2 answers. X is equal to 10, and it's also equal to negative 4. So with that in mind, absolute value functions are going to look different than linear functions because we need to represent solving twice. Once for the positive values and once for the negative values. So our absolute value functions are going to be V's. So the transformations that we just worked with last sections with lines is going to carry over to this section. Now, I bet if you had to on your own, I bet you could match up each absolute value equation with the graph below, just using what you know from the previous section about lines. So if I look at A, the first thing that I'm going to notice is that there is a negative out in front. So just like a line, that is going to be a reflection. So I'm going to look in at all my graphs that are reflected or upside down. The next part I'm going to look at is x minus 2. So this measures the distance just like when we were looking at lines, our horizontal shift from left and right. Because we are subtracting a number from the x value, that's going to represent a horizontal shift along the x-axis. Seeing how far a value moves is finding the difference. So when I am looking at x minus 2, the difference is positive 2. So I'm going to shift 2 units to the right. 1, 2 from our axis. Notice that there is no constant. I am not moving up or down. Therefore, D is our answer for negative absolute value of x minus 2. Looking at B, I have no negative out in front, so I am not looking at E or B. The plus 2 means that it is a vertical shift up. So I'm looking at a graph that has moved 2 units up. And then finally, that minus 2 is a horizontal shift 2 units to the right. So I went up 2 units, to the right 2 units. I have a positive slope, so I'm going uphill. My V is in the upward direction. So my answer is C, absolute value of x minus 2 plus 2. C, I'm looking at a negative, so I have a reflection. The plus 2 means that I'm going to shift in the opposite direction, so that's just like rewriting x minus negative 2. So I'm actually going 2 units to the left, and the minus 2 at the end means I'm going 2 units down. So 2 units to the left, 2 units down, and I have a reflection due to the negative. So this is E, the negative absolute value of x plus 2 minus 2. See if you can match up the remaining equations, D, E, and F with A, B, and F. Next, we're going to compare the parent function, which is already graphed on here. So this is our parent function on both of our graphs. Parent function, just like a linear parent function, is the most basic function for absolute value. It has a y-intercept of 0, and a slope of 1, up 1 over 1, up 1 over 1, up 1 over 1. Due to the fact that it's an absolute value, it'll always be reflected across the x-axis because we solve for the positive values and the negative values. When we did linear transformations, we recognize that adding a value onto our line, or in this case, absolute value, is going to be a vertical translation. So we are going to shift our entire line up 3 units. So we're actually just taking these same exact lines so if I copy them, and it's a shift up, so I'm going to go up 1, 2, 3 units, 1, 2, 3 units. So it's the same exact line, f of x, except we increase the y-intercept by 3. So we shifted up 3 units. When the value is being added or subtracted onto the x, it is a horizontal shift. So remember, just like in lines, it was x minus the value. All right, so since our value is positive 2, since we're subtracting a positive, this is a horizontal shift to the right. So same idea. We're going to take our lines and shift them 1, 2 units, 1, 2 units. They have the same slope because there is no factor or a multiplier out in front, so that's why the lines are still parallel, but the line has physically gone 2 spaces to the right. When it was a factor or a multiplier, that affected the steepness of the slope. So we're looking at our vertical stretch and vertical shrinks. When I have a multiplier of 2, that changes my rate of change. So instead of going up 1 over 1, up 1 over 1, up 1 over 1 before, we are now going up 2 over 1, up 2 over 1, up 2 over 1. My vertex did not change location because I have no constant and I'm not adding or subtracting a value onto x. So that means my vertex is at 0, 0. So that is part of my line. Due to the fact that it's absolute value, we need to reflect that over the vertex. So it's also going to go in the opposite direction. This is a vertical stretch. Our absolute value bars are skinnier, increasing in slope. Part B, we actually have to look at 2 parts. We have a negative, which means we're going to reflect and go upside down. And the 1/2 is going to change the steepness of our line. It's going to be less steep. Once again, no values being added or subtracted onto x, no y-intercept, so we're going to stay with a vertex of 0, 0. Since it's a negative value, I'm going to go down 1 to reflect, over 2, down 1 over 2. Notice that our absolute value is widening, and we called this a vertical shrink. When we go to graph this by hand, we're going to refer to vertex form for our absolute value. The vertex is either the top of the V, if it is upside down and reflecting, or the bottom of the V. So it is the point where there is a change of direction. To find the vertex form, or to find the vertex, we are looking for the point HK. This can only be true if there is no coefficient in front of x. If there is a coefficient, we need to factor it out and place it in front. That will tell us our rate of change. So the value of h is going to be the x-coordinate of our vertex, and then the k, which affects the shift up and down, is going to be the y-coordinate. So I want to compare my 2 graphs, so I'm going to graph twice, once for f of x and once for g of x by hand. So the first thing I need to do for f of x is I need to locate the vertex. So our vertex form is x minus h plus k. And if we have a factor, it would be a. There's no coefficient for x, so I don't have an a value. I can rewrite x plus 2 as x minus negative 2. Therefore, my h value is negative 2, and my k value is negative 3. That means the vertex of f of x is going to be at negative 2, negative 3. Then from there, I'm going to use my coefficient to tell me how many spaces to rise and run. My coefficient is 1, so I'm going up 1 over 1. And then I have to make sure that I reflect that across my vertex so that I am representing solving for positive and negative values. So I'm going to go up 1, back 1. So when I graph g of x, I have a coefficient of 2. That's not good because our vertex form is when x is completely isolated with no coefficient. So I'm going to factor out a 2. So a 2 comes out in front. I'm left with x plus 1 minus 3. Now I can look for my vertex. So once again, I can rewrite this as x minus negative 1. So my vertex is located at negative 1, positive 3. Oops. I made a mistake. That should be a minus sign. So negative 1, negative 3. So negative 1, negative 3 is where my vertex is at. However, this time I have a coefficient of 2. So that means my graph is going to be going up 2 over 1 unit. Up 2 over 1. I have to reflect across my vertex, so up 2, back 1. So if I were to compare the two, all right, starting from f over, we can see that it has shifted and it's also more steep. Last one, so just one more example to make sure that we have it. So this is in the form, our vertex form. So our very first step is to find the vertex. And our vertex is located at HK. Since it is a subtraction sign already, I do not need to rewrite this as subtraction. I just already know that my H value is 1. K is whatever my constant is at the end, so 3. So my vertex is located at 1, 3. The A value is going to help me decide my rate of change or how the graph moves. My A value is negative 2. That tells me two things: that I'm going to reflect across or upside down, and that 2, I'm going to have a slightly more steep line. So at my vertex, I'm going down 2 over 1, down 2 over 1, down 2 over 1. That is going to be reflected across the vertex. So down 2, back 1, down 2, back 1. And that is how I graph negative 2 times the absolute value of x minus 1 plus 3. And you can even do a quick check. Plus 3 means it's going to be a vertical shift up, which it is. Minus 1, we are shifting to the right, which it is. The negative is a reflection upside down, good. And the 2 means it's going to be skinnier. The steepness is going to change.